Hello, my name is Richard, and I am a C++ developer. In fact, I've been developing professionally in C++ since 1996, so it's a long time, but despite having been a developer for a long time, I definitely don't consider myself an expert in any way in C++. I would say, if anything, working so long and chasing weird, strange bugs in the middle of the night has really made me more of a conservative coder, and made me a little suspicious of elaborate design patterns and new language features. For most of my career, recently I've worked for a small startup that builds digital microscopy software, and this involved things like refactoring our legacy 32-bit application to take advantage of 64-bit architectures, making a system that can sort of simultaneously capture and process terabytes of data, and generally writing multi-threaded image processing algorithms, things like that. So like most people that fall down the Bitcoin rabbit hole, my first thought was, how can Bitcoin be attacked? And over the years, I've sort of focused on central points of failure and how that can threaten the resiliency and the privacy of people who use Bitcoin. Most recently, I've really become interested in the threats that come from centralized communication networks. And I've really taken inspiration from what Blockstream has done with their Blocksat to create an alternative communication system that both preserves sort of the privacy, but also makes Bitcoin more resilient. So in the last year, I quit my job of 16 years and went to work for a small startup called Gotenna. What Gotenna does is they make the protocols and hardware for the world's first consumer mobile mesh network. So what is a mobile mesh network? It's a system, instead of sending data to a centralized base station like you would today, you instead send a message, you would send your data to you would broadcast it to nearby nodes. And those nodes would relay the information from hop to hop to hop until it reached its destination. This, I think, would be good, and I believe will be very good for Bitcoin's resiliency by creating an alternative communication network. But most mesh networks and pretty much any peer-to-peer network suffers from the problem of needing a critical mass of users in order for the network itself to be useful. And so when I was hired at Gotenna, my task was to try to apply some of the concepts from cryptocurrencies to create an incentive system so that people would run mesh nodes to relay for other people. That works well, because one of the other limitations of mesh networks is that they have a trade-off between range and bandwidth and latency. But fortunately, Bitcoin already, as it's designed, is low bandwidth. Sending a Bitcoin transaction is low bandwidth. But unfortunately, it isn't necessarily good for our incentive system, because it is going to be making micropayments on a on-chain Bitcoin network is just not very efficient. So I was very excited in 2018 when Christian Decker, Rusty Russell, and Lalu announced their eltoo paper. What's cool about eltoo is that it solves some of these problems that the current Lightning update system has. I guess I'll skip to that. Sorry. So eltoo solves some of the problems that the current eltoo penalty system has for Lightning, and that is, it makes a more non-interactive payment system, and among other advantages, also theoretically could allow a payment to be made with only 2 signatures. So this I think could be really good for enabling incentives using a variant of the Lightning protocol to incentivize nodes. But I had a problem, and the problem is that I couldn't find, and there was no implementation of eltoo that I could look at to sort of learn from and build on. Also, I work at a company in which I'm the only Bitcoin developer. And I work remotely, so I work in my basement, and I don't really have any colleagues I could use to sort of discuss these ideas. So what I really needed was some colleagues who were familiar with Bitcoin that I could work with on this. So you can imagine I was very excited to be given the opportunity to work at the Chaincode Residency with a bunch of really talented Bitcoin developers. And the project that I decided to work on, of course, was going to be to implement an early test framework for the eltoo protocol. And as my mentor, I would have Christian Decker. So it's a really fantastic opportunity. And even though it meant leaving my home in Sweden and my family for the summer during the only months when Sweden actually has nice weather, I just was very excited to be a resident at Chaincode. So just to explain a little bit about how eltoo works, just like the current LN penalty system of updating Lightning channels, funds are locked in a 2 of 2 multi-sig account. And as payments are made, the balance of dividing that 2 of 2, the balance in the 2 of 2 multi-sig is split. You do that in eltoo by creating an additional transaction which settles to two outputs. So the first task I had was to implement a framework that could encode the Bitcoin script for eltoo and for settling eltoo transactions. But of course, in Lightning, transactions aren't going to be immediately settled. There's this idea of an in-flight transaction. And in-flight transactions are handled by a concept called HTLCs, a kind of transaction called an HTLC, which is a hash time lock contract. So this is also something I had to integrate into the eltoo system and make sure we had scripts for that would deal with that. And the way it works with the HTLC is a payment is made conditional on the receipt proving that that payment was transferred through the network to its recipient. And this is similar to how we want to use it for the mesh network, except for in addition to showing that a payment was received, we're actually using the HTLC to show that a message was delivered to some final recipient. So the second step was implementing, again, Bitcoin scripts that would make these settled HTLC transactions possible. But the real magic of the eltoo system is that you have this idea of floating or rebindable transactions. And this is what allows you to use the system to exchange updates without settling them immediately on a blockchain. And this is why Lightning itself is so good for a off-grid mesh network, is because you can delay committing these transactions and then rebind them to earlier update states if there's an unconditional or uncooperative close. And I should say, so this is done through a soft fork change to Bitcoin, which is sig hash no input. And this is a proposal, BIP 118, which makes this possible. So part of the work I did on this framework was to implement the sig hash no input in the Bitcoin testing framework so that it would work with a modified fork of Bitcoin that had this sig hash no input implemented. So the next step was to then, having this simulation in place, run it through a series of tests to make sure that the security assumptions of eltoo were correct. And that was things like what happens if an adversary were to commit an out-of-sequence update, or if you had somebody try to settle an earlier update, but without waiting for a newer update to be committed. Likewise, with the HTLCs, we had to see, the test framework had to test to make sure that or that the payer couldn't sweep the refund transaction until the person that was receiving the payment had time to present proof that they had that they had transferred the payment. And likewise, we have, the tests have to make sure that the payment receiver also has to prove valid proof that they delivered the payment before they could get paid. So putting all these together was, a series of tests that just are a way to prove that the eltoo security model is properly implemented in this initial simulation. And then finally, there's the happy path. So I implemented what happens when you do a series of updates that don't end up being uncooperatively closed, and making sure that the simulation could be used to simulate that situation where you do a series of payments and then cooperatively close between the two parties in a simple 2 of 2 transaction. So with that, we had a full, basically a full simulated framework for eltoo. And my hope is that this is something that other people who want to learn about eltoo can look at and have a better understanding from just looking at the paper. Now you can actually look at the code and see how this is literally implemented in Bitcoin. And also that this would be a way for people to be able to discuss alternative implementations, perhaps different scripting systems or different improvements on this system by making a modification and then testing it in this framework. So why hasn't there till now been an implementation? I think a lot of it has to do with the fact that the SIG hash no input soft fork is a bit controversial, mostly around the concept of the fact that these floating transactions could be replayed. So there's a lot of discussion going on about that. And my hope is that having an implementation out there can help people understand eltoo and sort of understand the motivation why we would like to have this no input SIG hash. And also, I believe that doing mesh incentives on an off-grid network where bandwidth is very important also provides an incentive for why we would want eltoo also. So I hope that having this out there can help contribute to that discussion. In the future, I'd also like to take a look at some alternative implementations that use some of the new soft fork proposals that are coming out, such as Schnorr and Taproot. I think there's some pretty exciting proposals out there for how to implement eltoo using the Schnorr and Taproot framework. And there could be basically more efficient on-chain and also more private implementations of eltoo, and possibly also more efficient in this off-grid mesh incentive application that I'm working on. There are other things you can do with eltoo that are hard to do with the existing eltoo penalty. One of them is having multi-party, and that's something that's much easier to do in eltoo, and for the mesh incentive project could also create an opportunity to use something like channel factories, so transactions don't have to as frequently synchronize with the blockchain. So that's an interesting area to explore. Also, with some other residents, I'm going to be working on creating a SIGNet testnet, which includes a lot of these advanced features like Schnorr and Taproot and eltoo, just to create a unified way for people to test this without having to run their own testnet with these features. So again, I hope that the particular mesh incentive project I'm working on at Gotenna can help provide motivation for eltoo and elucidate what it would be good for and what it would be one particular useful application. And I want to take everything I've learned over these last few months at Chaincode and use that to build a simple proof of concept of an application that uses eltoo to incentivize other nodes in the mesh in a mesh network to relay data. And ultimately, I hope that this is something that can be built upon and result in making something like a global mesh network a reality and a good alternative to our current very centralized network.